Hello, this is Hodar Hanoush. So today we will explain the chapter about probability. So we will make an analogy with the notion of or the concept of proportion in statistic. So to do this we will consider an urn that contains 6 black balls and 4 blue balls as we see. So the proportion of black balls is the number of black balls over the total number of balls, which is 6 over 10, and this is equal to 0.6. And the proportion of blue balls is the number of blue balls over the total number of balls, which is 4 over 10, and the answer is 0.4. And we can see that we don't have white balls, so the proportion of white balls is 0. This will help explain what probability means. So by definition, probability is a branch of mathematics that calculates the proportion of an event in relation to the set of all possible cases. So let's consider a universe omega that has several events A, B, C, etc. The probability to realize an event A is the number of cases that favor A, or the number of cases in A over the number of cases in omega. And the number of cases in A is the cardinality of A over the cardinality of omega. So the limits of probability or the bounding of probability, according to the formula that we have gave, the probability to realize an event A is the cardinality of A over cardinality of omega. We can conclude that any probability is bounded by 0 and 1. When the cardinality of the event A is 0, the probability is 0. It's an impossible event or empty set. But when the cardinality of the event A is equal to the cardinality of the universe omega, this probability is equal to 1. This event is called a certain event. So we know that this event will happen all the time, so its probability is 1. So to calculate any probability, we need to calculate the cardinalities of the set. In mathematics, counting is the determination of the number of elements in a set. It's generally obtained by counting or by calculating its cardinal using combinatorial techniques. So to calculate the cardinality, there are 4 methods: arrangement without replacement, permutation, and p-applets, or arrangement with replacement and combination. We'll start with arrangement. So arrangement is how we choose p elements from n elements without replacement, where p should be less than or equal to 1. The formula to calculate the arrangement is a and p, which is n factorial over n minus p factorial. But remember that n factorial is n times n minus 1 factorial, which is n times n minus 1 times n minus 2 times etc. times 3 times 1, 2 times 1. So it's a product from n to 1. By convention, 0 factorial is equal to 1, 1 factorial is 1, and 2 factorial is 2 times 1, which is equal to 1. Example: So we want to form a password of 4 different digits. The number of possible passwords is the arrangement of 4 digits from out of 10 digits, which is 10 factorial over 10 minus 4 factorial, and this is equal to 10 factorial over 6 factorial, and the answer is 10 times 9 times 8 times 7, and it's 5040 possible passwords. We have on a table for 5 different books. In how many ways can we choose 2 books? So it is the arrangement of 2 books out of 5 books, and this is equal to 5 factorial over 5 minus 2 factorial, which is equal to 5 factorial over 3 factorial, and the answer is 5 times 4, which is 20. Now we will explain permutation. So permutation, it's an arrangement without replacement of an element out of an element. So we want to arrange an element, and it's equal to n, and it's n factorial over n minus n factorial, and the answer is n factorial over 0 factorial, but we know that 0 factorial is 1, so the answer is n factorial. So, for example, to arrange 3 different books, Arabic, physics, and chemistry, there are 3 factorial equals 6 possible cases. So, here are the cases: Arabic, physics, chemistry, Arabic, chemistry, physics, physics, chemistry, Arabic, physics, Arabic, chemistry, chemistry, Arabic, physics, and chemistry, physics, Arabic. For example, 5 people, 3 girls and 2 boys, want to sit on a bench. What is the number of possible cases if a girl sit next to a boy? So to solve this, there exists only one case. So we can set one girl, then one boy, one girl, one boy, and the third girl. But we can permute girls and boys, so the number of possible cases is 3 factorial times 2 factorial, which is equal to 12. The girls as well as the boys are on the same side. So uh, girls, and boys, and boys, and 3 girls. And we can permute the boys and girls, so the answer is 2, because we have 2 cases, times the permutation of girls, which is 3 factorial, times the permutation of boys, which is 2 factorial, and the answer is 24 possible ways to set 5 people. Now, p-applets or arrangement with the replacement. What we mean is we can take a ball from the urn and replace the ball. So we put again the ball in the urn. It is a choice with replacement of p element among an element. So p can be greater than n because we are replacing the ball again in the earth. And the number of possible ways is n times n times n times etc. times n, which is equal to n to the power p, because we are doing this p times. So, for example, to form a 4-letter password, there are 26 to the power 4 possible passwords, because the alphabet contains 26 letters. Finally, we will explain combination. So, combination is the simultaneous choice of p element among n elements, where p is less than or equal to n. The formula of combination is n choose p, or c n p, which is n factorial over n minus p factorial times p factorial. So note that n choose p is equal to n choose n minus p, and n plus 1 choose p plus 1 is n choose p plus n choose p plus 1. We can use combination to find something missing here. So to find the expansion of a plus b power n, it is equal to the summation of a n minus x times bx times this is missing here times n choose x. For example, the director or the school principal decides to form a group of 5 students from the life science class, where the number of students is 25. So we have 15 girls and 10 boys. The number of possible groups that the school principal can form is 25 choose 5, which is equal to 53,130. The number of groups with 2 girls and 3 boys is 15 choose 2 times 10 choose 3, and this is equal to 12,060 groups. The number of groups made up only of boys is 10 choose 5, which is equal to 252 groups. Now we'll do an exercise about probability to apply all the formulas that we have explained. So consider an urn that contains 12 balls, 5 black balls, 4 blue balls, and 3 green balls. So we randomly choose 3 balls from the urn, and we consider the following events. The balls are green, the balls have the same colors, and the 3 colors of the balls are different. So we need to calculate the 3 probabilities in each of the following cases. The choice of balls is successive without replacement, so we choose one ball after another ball. The choice is successive with replacement, so we choose the ball and we put the ball again in the urn, and finally the choice is simultaneous. For the first question, where the ball are drawn without replacement, so P of choosing 3 green ball is a number. So we will choose the first ball, which, that has a probability of 3 over 12, because the number of green ball is 3 and the total number of balls is 12. So now we have only 11 balls and 2 green balls, so the probability is 2 over 11, and for the third ball the probability is 1 over 10, so the whole probability is 1 over 220. To choose 3 balls that have the same color, the balls should be either green or black or blue. So for the green ball, so we have calculated this probability. It's 3 over 12 times 2 over 11 times 1 over 10. But for the black balls, so we have 5 black balls, so the probability is 5 over 12 times 4 over 11 times 3 over 10, plus the probability of blue balls, and we have 4 blue balls over 12 times 3 over 11 times 2 over 10, and the final answer is 3 over 44. To choose 3 balls that have 3 different colors, the answer is 3 over 12 for the green ball times 4 over 11 for the blue balls times 5 over 10 for the black balls. And we know that we can permute the 3 colors as we did in the books, so we have to multiply by the number of possible ways to list the 3 colors, which is 3 factorial, to get the final answer, which is 3 over 11. For the second questions, where we choose with replacement the balls, to find the first probability, which is a probability to draw 3 green balls, the answer is 3 over 12 times 3 over 12 times 3 over 12. Why? Because we choose the ball and we put again the ball. So the number of balls and the number of green balls did not change. And the answer is 1 over 64. For the second part, we have to choose green balls or black balls or blue balls. And the answer is 3 over 12 to the power 3 plus 5 over 12 to the power 3 plus 4 over 12 to the power 3, and the answer is 1 over 8. For the third probability, choosing 3 balls that have 3 different colors, it's 3 over 12 for the green ball times 4 over 12 for the blue ball times 5 over 12 for the black ball times the number of ways to list the 3 colors, which is 3 factorial, and the answer is 5 over 24. Now we need to choose the balls simultaneously. So the probability of having 3 green balls is 3 choose 3, because we have 3 green balls, over 12 choose 3, and the answer is 1 over 220. For the balls of the same color, it's either 3 choose 3 for the green ball over 12 choose 3 plus 5 choose 3 for the black ball over 12 choose 3 plus 4 choose 3 for the blue balls over 12 choose 3, and the answer is 3 over 44. And finally, for the balls that have 3 different colors, either one blue ball, and which is 3 choose 1, or one black ball, and it is 5 choose 1, or 5 blue ball, which is 4 choose 1 over 12 choose 3, and the answer is 3 over 11. So using Venn diagram, we can understand different probability formulas. So consider A bar. A bar is the complement of A. So A bar and A form the whole universe, omega. So P of A bar, then it's equal to 1 minus P of A, because A bar is omega minus A, and the probability of omega is 1. So we conclude that it's 1 minus the probability of A. Probability of union, so A union B is A plus B, and when we take A, we have taken the intersection, and when we take B, we have taken again the intersection. but the intersection exists one time. So we have to subtract one intersection. And the answer is the probability of A plus the probability of B minus the probability of the intersection of A and B. So we can conclude the probability of the intersection. It is the probability of A plus the probability of B minus the probability of the union. So here A is A intersected with B bar, so A without B, plus A intersected with B. So the probability of A is P and intersected P of A intersection B plus P of A intersection B bar. Using De Morgan's law, we can conclude that the probability of the complement of the intersection of A and B is equal to the probability of the union of the complement of A and the complement of B. And the probability of the complement of the union of A and B is the probability of intersection of the complement of A and the complement of B. Now we'll move to conditional probability. So an event A may affect the realization of an event B. For example, if a patient is infected by a virus, the vaccine has a small effect than if the patient is not infected. So the event the patient is infected by a virus has an effect on the event the patient is treated by a vaccine. All of the above explains the conditional or the conditions to realize a given event. By definition, the probability of realizing an event A, knowing that the event B is realized, is given by PA given B, or P of A such that B happened is P of the intersection of A and B over the probability of B. Same for P of B given A, it's the probability of the intersection again over the probability of A. And now we can conclude that the probability of the intersection is the probability of A times the probability of B given A, or the probability of B times the probability of A given B. For the independent events means that an event A is independent from an event B if and only if P of A given B is equal to P of A. So to realize an event A, it may be independent from an event B, and if the probability of the conditional probability is the same as the probability of A, then these two events said to be independent. And we conclude that the probability of the intersection is P of A times P of B. Why? Because the probability of intersection is P of A times P of B given A. But P of B given A is P of B, so the probability is P of A times P of B. And now we can conclude the formula of total probability. So we consider an event A. So A is participated, or it shares some part of it with A, B, and C. But we have learned that the probability of E is the probability of the intersection of E and A, E and B, and E and C. So P of A intersected with A is P of A times P of A given E given A. P of A intersected with B is P of B times P of E intersected with B. And P of E intersected with C is P of C times P of E given C. And now we will solve an example to illustrate the conditional probability. So everyone in a village is injected with a vaccine, where 70% of people are infected by a flu. So we know that 15% of people who are infected by the flu have recovered, but 90% of those who are not infected have recovered. And this statement is represented by this tree. So we consider the two events G. The person is infected with the flu, and R, the person has recovered. So we need to calculate the probability of the intersection of R and G bar, or the complement of G and R. So we know that P of R intersected with G is P of R times P of R given G, which is 0.7 times 0.15, which is 0.105. So this probability is the probability of R given G. P of R given G bar is the probability of R times probability of R given G bar. R, probability of G bar times the probability of R given G bar, which is 0.3 times 0.9, and it is 0.27. And finally, the probability of R is the summation of R intersected with G times plus R intersected with G bar, and it's 0.375. Another example, consider now two urns. So U and V, and U contains 3 black balls and 4 blue balls, and V contains 3 black balls and 2 blue balls. So what we will do is we will choose randomly from one ball from U, and we will put it in V, and then we will choose randomly and simultaneously 2 balls from V. Let N be the event the ball drawn from U is black, and M the event the balls drawn from V have the same color. We need to calculate the probability of N and the probability of M. So we need to explain this question. We have two cases. If the ball drawn first, the probability of the black ball is 3/7, because we have 3 balls, 3 black balls and 7 balls, so 3/7. So there are two cases. If the ball drawn from you is black, we will have 4 black balls and 2 blue balls. But if the ball is blue, then we will have 3 black balls and 3 blue balls. So the probability of the event same color given black balls is 2 choose 2, because we have 2 blue balls, plus 4 choose 2 because we have 4 blue balls, over 6 choose 2, and the answer is 7/15. And the probability of the event M given N bar is 3 choose 2 plus 3 choose 2, because we have same number of black and blue balls, and the answer is 6/15, which is 2/5. And finally, the probability of the event same color is P of M intersected with N plus P of M intersected with N bar, which is P of N times P of M given N plus P of N bar times P of M given n bar, and the answer is 3 over 7 times 7 over 15 plus 1 minus 3 over 7, which is the probability of n bar, the complement of n, times 2 over 5, and the answer is 3 over 7. The third example. So in the previous example, the balls have suppose that the ball have different colors. Find the probability that the ball drawn from the RNU is blue. We can convert the statement into calculate P of n bar, the complement of n, given n bar. And using the formula, P of n bar given n bar is P of n bar given n bar over P of n bar. P of n bar given n bar is P of n bar minus P of n bar intersected with m over 1 minus P of n. But P of n bar is 1 minus P of n. So 1 minus 3 over 7 minus 1 minus 3 over 7 times 2 over 5 over 1 minus 3 over 7. And the answer is 3 over 5. To explain why P of n bar intersected with n bar is equal P of n bar minus P of n bar intersected with m, we use the formula of total probability of the event n bar, which is equal to P of n bar intersected with m plus P of n bar intersected with m bar, and the answer is P of n bar intersected with m bar is equal to P of n bar minus P of n bar intersected with m, and the complement of an event m is P of n bar 1 minus P of m. So now we have to explain the final part of probability, which is random variable. So random variable, it is a function defined from the set of possible results of a random experiment, of which one must be able to determine the probability that it takes for a given value or a given set of values. In summary, it is a function that associates to the event x equal x a probability p of x equal x. The mapping of probabilities for each value of x is called the probability distribution. So, and finally, we have to explain expected value, variance, and standard deviation. We throw a perfect dice of 6 faces numbered from 1 to 6. So the probability to see a face that has 1, 2, or 3, 4, or 5, 6, it is 1 over 6 because one face over 6 faces, so they have the same probability. The expected value of x is E of x is equal to the summation of the product x I of each value of x times its probability. So in this case, the answer is 1 times 1 over 6 plus 2 times 1 over 6 plus 3 times 1 over 6 plus 4 times 1 over 6 plus 5 times 1 over 6 plus 6 times 1 over 6, and the answer is 3.5. So the expected value of that we will see in a face is 3.5. But we know that 3.5 does not exist in the dice, and we know that this is the expected value that we will have, or the mean of x's. The variance is the expected value of x squared minus the square of expected value of x. So it is the product of I squared, which is the value that we have from 1 to 6 times its probability minus the expected value, which is 3.5 squared, and the answer is 2.91. And the variance is the difference or the summation of the distance or the mean of the distance of all the values of x compared to the expected value. So, and the standard deviation is the deviation of all values of x, or the mean of deviation of all values of x from the expected value. In this case, it is square root of 2.91 and it's 1.7. Thank you for listening.